We are coming closer towards the end of this module. In this lecture, I want to show you a very helpful command. It's about tagging commits. For this, we'll create a new folder here. Let's maybe call it, well, commits, because we will work on our commits here. And let's drag it into our new Visual Studio Code window. Let's close the welcome screen and bring back our panel and maybe clear this. Now, I'll create a new file. Let's say file one.txt. We'll know how this works in the meanwhile. And we'll, of course, initialize our repository, add this file, and say git commit -m, well, file 1, right? Then we'll add a second file, file 2.txt, and we'll also add this file to our staging area and commit it. File 2. And we'll do the same thing one last time with a third text file we create in here. So like this and like that. Okay, so far nothing new. Now, if we think about these different files, we could say that we have a specific milestone in one of these files in our project. For example, file 2 here could be our version 1.0, our first final version of our project. And to quickly find this commit, if you want to jump back to this, we can add a so-called tag to it. Tags are indeed made to tag such important stages in our project history, and we generally differentiate between lightweight tags and annotated tags. A lightweight tag is simply a pointer towards a commit in the branch, so it's basically like the branch itself, which points to the latest commit in the branch, the head commit. We had a look at this in the last module. An annotated tag, on the other hand, is a full object in Git. A full object meaning it contains information like the email of the person who added this tag. Typically, you work with annotated tags in your projects if you just use such internal tags for temporary reasons, so you just mark an interim version with 0.7 or something like that, which you want to remove once you have the final version, then you might also use temporary tags. This is something you can decide in the end in your individual project though. We'll just have a look at how we can add such tags and how we can work with these and how we can also remove such tags in the end. Now, before we tag our commit here, we can first have a look at any tags we might have in our project with the git tag command. If you do this, you get a list of all the tags you have. Turns out we don't have any. No big surprise in here. So to add the tag to our second commit, we first need to find out the ID, which we have right here. So we can copy this and clear this maybe. And now we add git tag. Now our tag name, which could be 1.0. This is a lightweight tag, so such a temporary tag. And now we simply add the ID. If we do that, you see no big change. But if we now enter git tag once again, we see we have one tagged commit. Well, this is this 1.0 commit. If you want to see which commit that is, you can simply type git show, also a new command. Git show allows us to display objects here or the content of objects in Git. Commits, for example, are objects, therefore we can use this command right here. So we type git show 1.0, and with that you see that this commit right here with that commit message is our commit with that corresponding 1.0 tag in here. You can even check out commits by using tags. So with our good old checkout command in here, oops, like this. So checkout 1.0, we refer to this tag. If we do that, we are again in our detached head mode. You know how this works in the meanwhile. So with that, you can also access commits, so you don't need the hash then in the end. Therefore, these tags can make it easier if you have to go back to older versions from time to time. You don't have to copy the entire hash. You can just enter git tag, you get the list, you see which version you want to refer to, and then you check it out like this. We can now go back with our git checkout master command. With that, we are back in our head. And if we want to remove this lightweight tag, we can also do this by simply adding git tag -d and now the tag version, which is 1.0, not 1-0, sorry, my bad here. So git tag -d 1.0 like this. Now we deleted this tag, and if we check out git tag once again, you see we don't have any more information about this tag. We don't have any more tags, to be more precise. We can also add a tag to our latest commit. For this, I want to use a so-called annotated tag, so a full tag object in the end. This works with the git tag command once again. Now we enter -a. Now the tag version, for example, 2.0. And now we can also add a tag message like we added in the commit message. This is the latest version right here. Let's confirm this. And let's again run git tag in here. As you see, we have this 2.0 tag. We can now also show this tag 2.0 like this. And in here, you can now also see the difference between this lightweight and this annotated tag. Here we can, for example, see the message we added to our tag. You can see the tagger, which is myself, and also the date when this was tagged. So therefore, typically you use annotated tags in here. You can of course also use the checkout command as we did it with the lightweight tag. As we are in the latest commit, this doesn't make too much sense at this stage. And if you want to remove this annotated tag, this again works with git tag -d and now our 2.0 here. If we do that, the tag was deleted, we can clear this, and with git tag we see we don't have any more tags left in here. Now that's of course a very quick command in the end, but it can be quite helpful to keep your project a bit more structured and to easily refer to certain milestones inside your project. So let me conclude what we learned in this module, at least the core concepts that we discovered. We had a look at git stash. Git stash is a temporary storage for unstaged and uncommitted changes. It helped us if you're working on a specific feature, for example, but you suddenly have to go back to the actual project status. You can then do this and access the information from the stash when it is required at a later stage. We also learned about the git reflog. The reflog is a log of all project changes made, including deleted commits, for example. We saw that we can use it to bring back such, well, deleted data, which can be helpful if you, for example, accidentally reset the head of your project. We also learned a lot about git merge. We learned that merging helps us to combine commits from different branches, and it either creates a new merge commit if we use the recursive merge, for example, or by simply moving the head with the fast forward merge, which means that no new commit is created in the end. Besides the merge, we also learned a lot about git rebase. Rebasing means that we change the base, so the parent commit, of commits in another branch. We had a look at the example that the master branch evolved, and at the same time a feature branch which was built up on this initial state of the master branch also evolved. We then used rebase to bring back the latest status of the master branch into the feature branch and base the commits we created in the feature branch on this latest status. Besides rebase, we also learned about git cherrypick. Cherrypick copies a commit, including the changes made only in this commit, and this commit then becomes the head of another branch. We saw the project example here with the typo we fixed, so with git cherrypick, we were able to just apply this change to our master branch, but it's important to keep in mind that we create a copy of the initial commit with a new ID though. This is it with the Git part now of this course. So far, we worked in our local environment on our machine. Typically, in bigger projects, you're probably collaborating or working together with other people, or you at least publish your code to a cloud provider. This cloud provider in this course, and also used in many real-world projects, is GitHub. Therefore, let's now see how GitHub works and how we can connect it to Git in the next module. Really looking forward to this one.